Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to explain about the construction of confidence interval for one population mean, and this is the case where the variance is known. So variance here refers to the population variance. Okay, so the confidence interval formula is given by this one here. The formula is given in the box, and of course, if you want to write it in a compact form, you can write it in terms of a point estimate plus minus margin of error, and this is just equal to x bar, which is the point estimate. So this is x bar, and then you have plus minus, and this is the margin of error, which is z alpha over 2 sigma over square root n. So I'm just writing the formula in a more compact form, and here x bar is the sample mean, sigma is the population standard deviation, n is the sample size, and this is the z value or z quantile, which refers to the horizontal axis here, and you can refer to the standard normal distribution table in order to find this z quantile here. So z quantile depends on the value of alpha. So alpha is basically equals to 1 minus the confidence level. Okay, so recall the usual value for confidence level is either 90%, 95%, and 99%. So these are the values of confidence level, and based on that, you will be able to construct the confidence interval using this formula. Okay, so confidence interval is basically stating the value of mu between two values, which is A and B. Okay. Now, suppose you are asked to construct a 90% confidence interval. So this 90% is actually the confidence level. So this is the confidence level. 90% is equal to 0.9. Okay. Then you need to find the values of this quantile here. So this is the negative value and this is the positive value. So you can see that because of the nature of this distribution is symmetric, okay, the standard normal distribution is symmetric, therefore this value here is equal to this one, and the difference is just with regards to the negative and positive sign. Okay, so suppose you are asked to construct a 90% confidence intervals, therefore you need to find what is this value here. Okay, so I'm going to illustrate this example using both tables. Again, just for clarification only, and then maybe in the next examples I will just skip this part, assuming that you are well equipped to find these values on your own. Okay, right, now let's go back to the examples here, which is to find the values for z alpha over 2. This is a positive value and this is the negative value. Okay, so this is 0. So when it says 90% confidence interval, CI is confidence interval, so 90% here is the confidence level. So this 90% here correspond to the area in the middle, which is supposed to be equal to 0.9. So if this is equal to 0.9, therefore since it is symmetric, this is 0.45 between this and this is 0.545, and between this to this is another 0.45, and therefore the sum of this area is equal to 0.9. Okay, so we need to find what is this value and this value. Okay, so if you look at table 3a here, you can see that the value of z, which is the horizontal axis, which is what we're going to find here, are positive values. Are positive values. So these are all positive values. So these are the values of z, yeah. And so we know that it is referring to the values on this side, on to the right of 0, because this is at point 0. So values to the right of 0 will be positive, and values to the left of 0 is negative. So now we are going to, in order to use this table, we need to know what is the, okay, I'm just going to illustrate this with another figure here. So basically we want to find this one, z alpha over 2, and if I want to use this table, I need to know the area from z to the left. So I need to know this area to the left. So since I know that this is from this to this point is 0.5, and from this to this 0.45, so this one to this one is 0.45. Therefore the area is going to be 0.5 plus 0.45, it is 0.95. Okay, so the area from this point towards the left is 0.95. So I need to find where is 0.95 inside the table here, because outside here is the value for z. So the probability is 0.95. I need to find where is 0.95, or any value that is closest to 0.95. So if you look at this, you will see that the value will be either this one or this one, because both of them are equally close to 0.95. Okay, so let's say I choose this one. Therefore my value, which is therefore my z alpha over 2, which is this one that I'm looking for, is going to be 1.65. And because this distribution is symmetric, I know that the value here is going to be negative 1.65. So that's how you can find the values for z quantile using table 3a. So let's try and use another table, which is table 3b. Okay, so I'm going to again sketch the area that I'm looking for, and to use this table, I need to know what's the area on the right tail of the distribution. So if this is my z alpha over 2, which I would like to find out what the value for this one is, I need to know what's the area on this side. Okay, so again, since I already know that the value here is 0.95, yep, so this is the value here, 0.95. Therefore this value that I'm looking for is 0.05. okay, so this area here is similar to the area shaded on this table 3b. So the value here is 0.05. So this is the value that I need to find inside the table given here. So where is 0.05? You will see that the value here will be either this one or this one. Okay, so you can choose either one of those. So let's say I choose this one. So the value of z in this case is 1.65. So therefore z alpha over 2 is 1.65. And again, because standard normal distribution is symmetric, we know that this value here is also going to be 1.65 with a negative sign. Alright, so I think that's all for finding the z quantiles on the standard normal distribution. So let's look at the example here. So a survey of 30 adults found that the mean age of a person's primary vehicle is 5.6 years. So therefore this is the result from the sample. So this is the sample size, and the result is the mean. Okay, based on the sample size, the mean age of a primary vehicle is calculated. So this is referring to x bar. Now, assuming the variance of the population is 0.64 years, so variance of the population is sigma squared, and sigma squared in this case is known, which is 0.64. Now, find the best point estimate of the population mean and the 99% confidence interval of the population mean. So there are two questions asked in this example here, and assume that data comes from a normal population. All right. So for the first question here is to find the best point estimate of the population mean, and we have learned that if you want to find the population mean, the best point estimate is x bar, and x bar is given already, you know, it is already available in this example here. So x bar is equal to 5.6. so this is the estimate of the population mean. Next, we are going to find the 99% confidence interval for the population mean, and because variance of the population is known, we know that we can use the formula given here, which is x bar plus minus. So this is the z quantile from the standard normal distribution, and this is sigma square root n. Okay, so this is equal to the value of x bar is 5.6 plus minus. Now we need to find the value of z alpha over 2, and then sigma is 0.64. This is the variance, so we know that sigma is going to be taking the square root of 0.64 next over the square root of 30. Okay, so now we need to find what is z alpha over 2. So if I sketch the required 99% confidence interval, basically it is saying that this one is the confidence level where the area here is going to be equal to 0.99. So 99% is the same thing as 0.99, and we know that alpha is 1 minus confidence level, so 1 minus 0.99, and this is equal to 0.01, right? So this is equal to 0.01, and therefore based on the slide, on the previous slide, we need to know what is this area. So this area is alpha over 2, and this area is also alpha over 2. So in this case, alpha is 0.01 divided with 2. Now this area is going to be 0.005, and this is also 0.005. So our job is to find what is this point here, z alpha over 2, and this one is negative z alpha over 2. This is a z quantile. Now you're referring to the horizontal axis, okay, on the standard normal distribution table. So now from the standard normal distribution table, you should be able to find 0.005 inside the table. So this is the area. Okay, so this one is the area or the probability. So you need to find where is 0.005 is. And based on that, you will be able to read the value of z. And the value of z is just going to be equal to either 2.58 or 2.57. So I trust that you can do this on your own, and you will be able to get this one is equal to plus minus 2.58 or 2.57, depends on your preference. That's okay. And then you can just multiply with the result of square root 0.64 over 30 here, and you should be able to get that the result is about 5.6 plus minus 0.3768. Okay, and therefore the confidence interval for the population mean can be written as mu between 5.22 and 5.98. So this is the mean age of a person's primary vehicle in years. So this result is in years. Okay, all right, I think that's all for now. Thank you very much for watching.